Hello, fellow learners. Welcome to Maths Bridge. Thanks for joining for continuing our learning in ML, machine learning. Today we are going to look at as part of agenda the basic concepts of regression analysis. At times we need to apply our skills to solve the problems. Do you agree? Let's say for instance untimely rains causing a farmer distress because where the people work for their lifetimes to buy certain things like in house and then eating like an evening meal, or predicting like in a weather, things like that. So all the problems related to the social, to handle the social problems, obviously we would like to have some kind of a statistical concept which actually is going to help us to do some kind of a math model or to predict the outcome of the particular event, isn't it? That's why the regression analysis is kind of like a technique, a machine learning technique which we use widely. Folks, please do visit us at our YouTube channel Maths Bridge. I'm sure I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. So let's look at what is mean by regression analysis. So we know that a regression is a part of your supervised learning technique, which is used for modeling a numerical data, isn't it? So regression analysis is like a technique used to find out a correlation between the data points. So let's say you have the huge data, and then what you are trying to do is you are trying to find out a relation between the data points is what basically like a regression analysis. You have to understand the nature of the problem. If you are trying to understand correlation between the yeah, two elements or the that is where I think the regression analysis is going to help you. This technique is used in that context is what I was trying to let you know. So if you look at it in a precise definition, there are many, but this is one of them. In statistics, regression is a model for analyzing a relationship between two or more variables and determining if the changes in one variable are associated with changes in other variables. That is how you can see it out. Okay, let's say if you look at this diagram, what we have seen here is that there is a x-axis and y-axis. The probably by changing the x value there could be a change in y value, and then if you can plot the points, this is how it look like. This is a sample example for y is equal to mx. All right. So the regression is a statistical technique that relates a dependent variable to one or more independent variables. A regression model is able to show whether changes observed in dependent variable are associated with changes in one or more independent variable. Let's say for instance a person's weight based on their height, right? We have the relationship, no? Height versus like a weight, isn't it? So for example, you can take any formula where I have seen a simple example like weight equal to some constant 50 plus some multiplication factor 0.5 into height. So somewhere else the height is basically independent variable, but the weight is based out of the height. Based out of the height, the weight can be estimated using this formula. Whether it is right or wrong, that is a different question, but this is kind of a simple example helps you to understand how the regression analysis can be done. So the bottom line is the relationship between number of calories consumed and weight of the person is also kind of a regression problems. Likewise, we have many like predicting the house price, the rental price, and these are all kind of like context where the regression analysis is widely used. Let me take you to the simple tour. Assuming that I have a data something like this. I'm sure I think I don't know what this data mean, but I'm trying to figure that out how I'm going to actually correlate them, right? So when you look at this data, one thing that for sure that we know, because this is like a supervised learning, isn't it? So in the supervised learning, we know the label data, right? So I would assume that, like, the X means this is like an independent variable. That means like this is not depending upon anything else. It is just exist by its own. And then Y is a dependent variable. Dependent variable means like this is going to depend on X. What that means is, and mathematically, if you can express this idea, any change in X, when any change in independent variable may affect output of dependent variable, because Y is a function of X. So, but I don't know the relationship, but that is where I think we are trying to find out, isn't it? So if we can plot these all the data points, this is how the graph look like. So the X is an independent variable. You are going to take the X axis, and then on Y axis you are going to represent the dependent variable nature. So if you can try to use these points and the graph and then trying to put them as a points, this is how all the points are representing. It sounds to me this is like a linear relationship between X and Y, isn't it? Linear relationship means that they're fixed proportional in change for point to point. That is how I can see a multiplication factor probably exists here in simple math model. Correct. All the dotted lines is basically like in a curve. The regression line rather than curve. It's a line. So we call it as a regression line because this is going to help you to predict understanding the current relationship and then predict the future values. Okay. It is a process of finding a function that fits a subset of variable data. Regression analysis means it is a process of finding a function that fits a subset of, if not all the variables, at least a maximum. What are the what are the points that actually going to touch your the regression line would be your in a function. Basically, what we have to understand in this case. So regression analysis is one of the fundamental technique in machine learning and is used to predict future events. I hope you're clear. When you have concept called a regression analysis, one thing that reminds me, because of the data points and then the relationship, there could be like a linear relationship and non-linear relationship. What that means is, if you either the increment or decrement, if the dependent variable is basically outcome, right, and X is like an independent variable, if the relationship is actually kind of in a positive, like for a change in X value, if there is a change in Y in the incremental order, then what we can call it as is a positive regression. But if it is a linear relationship, then obviously we can call them as a positive linear regression. So if you look at this one, this is an example for the negative regression. The reason behind here is like for the change in X, there is a change in Y, but the Y is in the decreasing order, and hence this is called negative regression. But the change is also kind of a linear, and hence this is like a negative linear regression analysis, right? This is kind of like a linear regression. But there is a concept called a non-linear regression, meaning your regression line by itself is like a kind of a curve, right? It's not like a straight line. So this is called as a non-linear regression. Because it is like a change in X, change in Y are kind of a positive direction, means like if the X increases, Y also increases, and hence we can call it as this is like a positive non-linear regression. There is a one more you could think of similar to this negative regression. Negative non-linear regression could be like in a curve in nature. Your regression line is a kind of a curve in nature, but is in downward direction. So if you can restate the definition, the regression analysis is a statistical method used to examine the relationship between one dependent variable, often called as outcome or target or response variable, and one or more independent variables is known as the predictors, features, okay, or exploratory variables. Are you clear? The goal of regression analysis is to model this relationship so that you can predict dependent variable based on values of independent variables. How sweet. Well said, isn't it? Regression line is nothing but a model. So a mathematical equation that describes the relationship between dependent variable and independent variable. So if you look at this diagram, which is little different from the previous one, basically the same linear positive regression line this is, but the line starts at some constant on y. So when x equals 0, y is some definite value. That's why this equation can be represented in y equal to a plus bx, where a, b are the constants, x is a dependent variable, independent variable, y means like a dependent variable. It's also known as a predicted outcome, basically, right? So a means an intercept. A constant value is nothing but intercept. What that means is when x value 0, there is a y value. So y has some value when x equals 0 is nothing but intercept. And then you can think of a slope. What is meant by b is basically a slope. Slope means change in y for a 1 unit change in x. If you can look at this way, so if we, delta x is what this width, delta y is this one. So delta y by delta x, right? Difference in y divided by difference in x is nothing but your slope, is what is a b. So when you plot the graph, that you would be able to understand what is meant by y, how you are going to calculate the y for a given value of x. This is like a simple regression line model. There are some types of regression analysis that we have, something like a simple linear regression, multiple linear regression, polynomial regression, logistic regression, ridge regression, lasso regression, stepwise regression, non-linear regression, and then these are basically like it tells you like how the relationship is versus like what changes, and then when to use and all. So if you drill down more in detail like how the regression analysis is going to help you to solve the problem, you automatically can pick like which type of regression that you need to solve your problem statement. Let's have a quick demo. Here I'm using like in a simple Python code and then some simulated data for generating a simple regression line. So these are the few steps that we are going to take a look at in our demo, and then see like how the graph look like, which is basically like building relationship between dependent variable versus like independent variable, is also known as a predicted value. Here is the sample graph. Alright, here is the my demo on linear regression. So let's demonstrate the concept of linear regression, simple linear regression. What I am using here is like in a Jupyter notebook as my interface, where I can actually build my linear regression using Python code. So here is my cell. If you look at the cell 1, what I would see here is that there is a 3 libraries that I'm using for this building a model: NumPy, Matplotlib, and then sklearn. NumPy for the numerical operations, Matplotlib is for plotting, sklearn is for the linear regression, because I need to use the linear regression method and then giving input data set as an input, and hence I would actually see the regression line generated by this method. That's an idea, right? We are going to fit the all the data points into a line. That's what I mean by regression, right? So okay, let me execute this line. So did okay, as soon as you actually execute that particular line, it is going to give like kind of a star value. That is how I think you will know that this is all done. In the second step, what I'm going to use like a data set, I created a sample data set. However, you can actually download this data set from in a different file format, like Python supports a CSV file and Excel text file, that's short. So you have a like mechanism in Python to import the file, read the content from the file, load it in the variable. So here I am using like a simple, very simple data set. It's not a complex data set, but you still can use the complex data as well. Okay, I'm using like the two variables which get loaded, my data set into these variables. NP means like a numpy dot array is what I created here. So if I'm going to run this one, and then just look at like how I'm going to print. Yes, height can be printed because I'm reshaping -1 to 1, so it's vertically I'm displaying them. I can execute the same thing, so I can see it's like horizontal line. All right, that's the difference that you can see. Now I have the data set. What is the next step that we'd be doing in building a model? We are going to split the data into two parts, like a training data and the test data. So this is a method that I'm going to use, train underscore test underscore split. What is the inputs for this is like, you I'm giving like two input parameters as a data set, and then two more I am going to give it like test data size 0.2, which means from a given data set 20% of data can be considered test data, rest is 80%, right? That is like a training data. So I had a split in this step. So what this like a random state 42, what that means is every time you run this, right? Yeah, how many times that you're gonna run this this algorithm, always it picks the same sample for the test, same samples for for the train data. This is good, right? The consistency always there. Otherwise you are going to get like a different answers for small data set itself. That is how this is going to help you. Okay, let me run this one. Great. Let me print. Okay, this is a sample that I'm using like train, x train. This is kind of a test data. Two samples looks like it's picking. Similarly we have the train, and then we have the test data. That's good. Now think about like this is all like a kind of a supervised learning, right? So because of label data, you know what is going to get it from the given data set, but you are trying to create a model. So this is a the step where you are actually building a model for a given data set. Let me execute this one, linear regression, and then fitting the curve, right? Basically like a line, regression line using these data sets. Okay, great. Now I have a training is done, so I have a model ready. What I'm going to use like a model that predict for a given x, I should be getting like y is a prediction, right? So let me do this. Great, I did this. Very nice. I could actually see because what is your test samples? I have a two samples using as a test data. For these values, what I am getting is like y value, prediction value, isn't it, right? So that's good. So I could see the model is working, but I don't know like whether how much accurate that you have. So if you look at like the expected values like 160 and 120, what I'm getting is like what I'm getting here is in the prediction 159, 118, more or less same. But let me run through my evaluation process. What I'm going to use for my evaluation, right? So I am using like mean squared error and then r squared. These two basically metrics going to give me a confidence that like how much error that I have, how accurate I am. Yeah, that's short. Once we have evaluation done, your model is ready. What you are going to do is like you just plot the graph using this step. So let me run through it. Very great. So I could see now a complete graph of linear regression, right? So what are the data points? The line maximum touches these points. This could be my final regression line. There are the points which are like a little away. So that's why a subset of data points are going to be considered for drawing a regression line. You can use like the very complex data as well, but here we are using a simple data to demonstrate a linear regression concept. I hope this helps. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.